Okay, how you guys doing today?
Good.
Cool. Fantastic. I'm glad to hear it. So last time we talked a little bit about using functions, and we created a couple of functions and we called them, and we were actually able to simulate two sensors, right? Like the line sensors that we're going to be using in our midterm. So we simulated the inputs from those sensors, and then we called different functions depending on which sensor was giving us the input. So if the left line sensor was detecting the line, then that meant the car was too far to the right, so it had to turn to the left. So we had to call the turn left function, right? Similarly, if the right line sensor detected the line, we called the turn right function. And what function did we call if neither sensor was seeing the line?
Go forward.
Go forward, exactly. So we were able to read input values from the outside world and make decisions about what to do based on those inputs. So that got us a long way towards the code that we're going to be using for our midterm. In fact, that code that we wrote last time is going to be the foundation, the basis for the midterm. We'll talk a little bit more about sensors in an upcoming class so that we know how to hook those up. But really, those sensors are just going to take the place of the little simulated circuits that we had last time. The code is not going to change very much. You guys can tweak it around to try and make it go a little faster, do all you can to optimize it, but the basic code is going to be the same. Okay? So, did you guys have any questions about what we did last time? Okay, cool. So this time, we're going to do a little bit more about programming. This time, we're going to start doing, we're going to start using multiple cores, okay? So I think I mentioned at the beginning of the semester that the Parallax propeller chip has 8 different cores, and you can use them to run up to 8 different things all at the same time. So far, we've been running our program just on a single core, so it's only doing one thing at a time. But today, we're going to learn how we can use multiple cores to do several things at once. When we're doing that, we want to be able to communicate between the cores. So we're going to use an idea called variables. Variables are places where the computer can store information. So we're going to write to a variable from one core, and then we're going to read it from another core. So we can do communication between the cores that way. Okay? Yeah?
Where's the information stored on the core?
The chip has some memory, and it puts the information in the memory.
Is built in, or you can change the memory out?
It's built in.
Oh, okay.
Yeah. The board that we use has a place where you can put in your own micro SD card. So if you needed to store large files, you could store it on that.
Oh, you can run them off of there?
Yeah.
Oh, wow.
Yeah. So
cool.
yeah, it's pretty powerful.
Yeah.
Yeah.
How large does the board natively can store? How big a file?
That I don't know. We'd have to look it up on the website.
Wait, do you know what size of a micro SD card it can take up to?
I don't know that either.
2 gigs max.
Okay.
Okay.
Now, it'll take a bigger one, but it's only going to treat that like a 2 gig card.
Okay. So yeah, it's still 2 gigs of data.
Oh, those things are pretty cheap,
A
so.
lot of data.
Yeah. So, so we're going to learn how to use multiple cores. We're going to use variables. The third thing we're going to do today is we're going to use the serial terminal to gather information from the user. So last time we published a little bit of information to the serial terminal that was telling us when each sensor was detected, right? So we had that little output that was either zeros or ones depending on whether the sensor was low or high. So we were publishing data from the chip. Today we're going to use that same serial terminal to not only publish information but also take in information. So we'll be able to type in some information and the chip will read that and then process it, and that'll affect the way that our program runs. Okay? So the program that we're actually going to run today is we're going to make a little LED blink, and we're going to be able to type in the speed that we want the LED to blink, or the amount of time that we want it to stay on. Okay, so we'll type in 1,000 and it'll stay on for 1 second, and it'll just keep blinking. And then as soon as we type in 2,000, it'll switch over and it'll start blinking at 2
seconds.
2 seconds long. Yeah, exactly. It'll stay on for 2 seconds and go off for 2 seconds. So normally this would be very difficult to do if you were just writing the code on one single chip or one single core, because you would need 2 separate things happening at once. You'd need the part of the program that's making the light go on and off, and then you'd also need the part of the program that was sending information over the serial terminal and reading the information back. So it's hard to have both of those things happening at once. Normally the part that would be reading the information back would just stop until it got some information back. So it would not be able to make the light blink. So, 1 second. So what we're going to do is we're going to break that program up into 2 parts. So one part is going to do the serial communication, and that's going to run on one core. And another part is going to make the light blink, and that'll work on the second core. So by dividing them up, it actually makes the program pretty simple. Right? Yeah.
So if you were to run them on one core, it would actually slow down the processing of the core because it has to do so much. Is that what happens?
Well, it's not that it's any one task is so difficult, but the tasks are, the serial read is something called a blocking task, which means that the program gets to that task and then it just waits there and it doesn't do anything else until that task finishes. In other words, until the user types something in.
So it's a standard line, basically.
Exactly. So it gets there, and then if you had your blinking part of your code below that, it would never get to there because it was waiting for input from the user. Yeah. Yeah. Other questions? All right. So that is the general outline of what we're going to do. We're going to make the program cause the light to blink. We're going to use something called pseudocode. Pseudocode is sort of like a thumbnail sketch of a program. It's where you write out what you want your program to do in words before you actually make the program on the computer. Okay? So this is sort of like doing a hand sketch of a house before you draw out a blueprint. All right? It gives you an idea and helps you remember what you're trying to do when you're actually making the blueprint itself. So you can write out the pseudocode first and get your ideas down, and then translate that into actual code. So in this case, I've written out the pseudocode. I have it on the Canvas website for you guys to look at, and you guys will be able to look at it and translate that into actual code. So if you don't know exactly how your code is supposed to work, you can refer to the pseudocode, and that should prompt you and hopefully point you in the right direction. Okay? So we'll be referring to that during the lecture today as well. So this is the pseudocode that I have. The main goal is that we're going to create a program that runs on 2 cores. So the way that we do that in Blockly is that we create separate functions. So if we want something to run on a core, we put everything that we want on that core into a function. Okay? And then there's a handy command that we can use that says launch this function in its own core. All right? So when we're writing the program, we write out everything that we want in one function, and then we can launch it into its own core. So since we want this to run on 2 cores, we're going to create 2 functions. There's going to be a communication function and a blink function. And then the main program will sort of handle get everything going. Okay? So the communication function is the part that talks over the serial port, or basically that terminal that we see on our window. The blink function just deals with making the lights blink. and then the main program initializes everything and gets everything going. Okay, so that's the outline of what we're going to do. So let's see how this is going to actually work. So I'm going to create a new project. I'll call it Multicore here. The device type is the propeller activity board WX, just like before. So then we'll say finish. And now I have a new blank project to work with. So I'm going to refer to my pseudocode over here. And it says I'm going to create two functions, a communication function and a blink function. So I can go ahead and do that over in block loader. So I'm going to go here to functions, and remember to create a new one, I just drop a block like this down, and I will give it a name. And I'll do another one for blink. So now I've got the two functions. I don't have anything in them yet, but I at least have created them, right? So what I'm going to do now is that I'll take a look at the serial communication function, okay? So it says that I'm supposed to use the serial terminal to ask the user for a delay time. So let's dig in there and see a little bit about how that is actually going to work. So what I'm going to do is I'm going to go over to the communication menu on the left-hand side. And I'm going to use the terminal blocks. Okay? So I'm asking the user for a time delay. That means that I have to print a message to tell the user to put in a time delay. So I will use the print text function. I can specify what I want to say, so I will print out, please enter a delay time in milliseconds. Okay, so I got that going. Now I can actually run this program and just make sure that it's doing something, right? I like to run my programs early and often just to make sure that they are doing something, make sure that I've got the simplest parts working, and then I can build on them as I go along and get more and more complicated. And then if the program suddenly stops working, I'll know that the last thing that I put in is what made it break, right? If I just build up a really complicated program and then test it out and it doesn't work, I don't know where the problem is. But if I build it up just step by step, then I can always tell that the last step is what made it break, and that really helps to narrow down the territory where I have to look for my mistake. Okay? So I'm going to run this. Well, first of all, I'll save it, and then change the COM port, and then I'll run this and see if it does something. All right. So
You haven't called your functions yet.
Ah, thank you. Very good. Very good point. Yeah, so I didn't do that thing that I told you guys always to do. Right? Yeah, so that's an excellent point. I have created the functions, and the computer knows about the functions, but like you mentioned, I haven't actually called them, so I haven't told the computer to run them, so I have to do that. So I'm going to go up here to functions, and then I'm going to run my function called communicate. So let's try this again. Okay, perfect. So it's telling me to enter a delay time in milliseconds. So That's all it's doing yet. It's not saving that information. It's not actually retrieving that information. But at least it's doing something, right? So I know that it is, at least that part is working. So now what I have to do is I have to actually read the information in. So the user's going to type in a number and I have to read that number. So I'm going to go back here to terminal and then I'm going to grab this. So I'm going to use this block here that says terminal receive a number and store in item. Okay, so receiving a number sounds pretty promising, right? That's what we want to do. We want the user to type it in and then we want the program to receive it. Yes?
How many bit, so you mean the computers over here are 32-bit?
They're mostly 64-bit
64?
processors.
Yeah, because if you grab something like information that's meant for a 32-bit, it's not going to work with a 64-bit system.
Well,
Or a 64-bit system stuff won't work with 32-bit.
right, so this can be a little bit confusing. This says a 32-bit integer. Now, that doesn't mean that it has to run on a 32-bit processor, though, because this is just specifying the size of memory, the amount of memory that the computer is going to allocate to store this number. So it's going to put aside 32 bits, that's 32 little ones and zeros, to store this number.
So you don't have to worry about kind of take it with a grain of salt, huh?
You just have to understand exactly what it's doing. So what that means is that it can store any number between 0 and 2 to the 32nd power. Okay, so that's a really big number. That's much bigger than we need, but it's fine. It's not really, it doesn't cost as much. So, so we'll just leave it there. And then, so it's receiving the number, and now it's telling us that it's going to store it in this thing called item. So what that means is that it's going to try and store it in a variable, and we have to specify what variable we want to use. Now, we haven't talked about variables yet, so let's talk about variables for a second. A variable is a little place where the computer can store information while a program runs. So if you are counting up from 1 to 10, say, and you want to remember what number you're on, you could put that number in a variable. In our case, we're going to have the user type in a number, and we want to remember that until the user types in something else. So we're going to put that number in a variable. Okay? So you can create your own variables to store this information that you want to hang on to. So that's what we're going to do. We're going to come up here to variables, and we're going to put down a new variable up here. So right now it's just called item, but we're going to click on the down arrow and create a new variable and give it a name. So we'll call this the delay time. And I always like to put in the units that I'm using. Because otherwise, you know, I think the delay time is in milliseconds, but the next person who comes along thinks it's in seconds, and then adds on to the program based on that, and things get all screwed. So anyway, so I'll put that down, and I'll create an initial value for it. So initially, well, let's make it 1,000 to start out with. Okay. So now we've created this variable. Now we can write to this variable, or we can read from the variable. When we write to the variable, that means that we're putting a number into that little spot in memory. When we read it from the variable, that means that we are accessing that memory and getting out the number that has been stored there. Okay? So we can write to the variable or read from it at various points during our program. And an important thing to note is that you can access all variables from all different cores. So I could write to that variable from one core and read it on a different core. And that's what we're going to do later on. Yeah.
When you create a new variable or a new variable, would it like when you store in item, when you click that tab on the function, it would open up and it'll say delay time ms.
Yes, exactly, exactly.
So it's just like how we did the functions. It'll save them as just a new function key piece and you just add to that.
Yeah, yeah, exactly. So the Blockly language is pretty smart like that. When you create a new variable name, that automatically gets populated to any place where you might use a variable. So like you said down here, now instead of saying we're going to store this number in item, we're going to come down here and we're going to choose this delay time ms. That has automatically been added to the menu. We can just pick that one. So now our communication function is saying, it's asking us to enter a number, and then it's storing that number in our variable. Okay, so pretty slick, right? And then the next thing I want to do is I want to actually print out a message that confirms that we have gotten that number. Okay, so I'll put a new line in here. So I'm going to copy this, and then I will change the message. I'll say the delay time is now, and then I will leave it blank. And then what I'm going to do is I'm going to print a number. Okay? So I'm going to print a number, and in this case, I'm going to get rid of this, and I'm going to print out the delay time. So to do that, I'm going to go back up to variables, and then the delay time milliseconds. Okay? So now we should be able to run this, and it'll actually take in the information that we type in, and then print it back to us. So let's give this a try. So I will say 500, and I hit enter, and it prints the information back for us. Okay, so that confirms that it received that data, and it's now stored in our variable. Okay. So we're doing pretty well there. Okay, so now I've got the communication starting to be built up. So now I want to go on to the other function, the blink function. So the blink function says, my pseudocode says the blink function should make the light turn on and off. And in between, it should wait for the delay time. So if my delay time is 1,000, then the light should be on for 1,000 milliseconds and off for 1,000 milliseconds. If my delay time is 500, it should be on for 500 and off for 500, and so on. So let's see if we can do that. So to turn the function on, or to turn the light on, where do I go for that? You guys remember? In states, yeah. So I'm going to use the built-in LEDs again. Those are on 26 and 27. So I'll make pin 26 high. And then I'm going to go and up to control, and I'm going to do a pause here. Now, instead of waiting for a fixed amount of time, what do you guys think I should put in this little slot?
Variable.
Yeah, my variable, my delay time. So I'll go to variables, and then I can just grab this delay time and shove it right in there.
Nice.
Yeah, and then I can duplicate this, and I will make this low. And then I can duplicate this again.
Nice.
Yeah. Now, how many times is this light going to blink if I just run the function as it is? Once, exactly. And we don't want it to blink just once. We want it to keep going over and over again. So what do I have to use?
Control function. Control loop.
Yeah, a loop. Exactly. So, yeah. So I'm going to go over to control, like you said, and then I'll grab this repeat forever loop. All right, so now I got my blink function to make the light blink on and off, and it's gonna wait for the delay that I have there. Okay, so I've got my two functions going pretty well, and now I want to build up the main program. So first thing says initialize delay time variable. So I've got that. I'm creating an initial value for my delay time variable. And it says launch the blink function and then run the communication function. Yes,
Why is the initial time 1,000?
I just picked that.
So you can put whatever?
Yeah, anything you want.
Okay.
Yep. You just need to put some number there so that it has some value to start out with.
Okay.
Yeah. Otherwise, if it had no value to start out with, it wouldn't know how long to make the light blink, and it would freak out. I don't think it would work.
Okay.
So, so then I have to launch the blink function in its own core. Remember, that's going to run in its own core so that it can happen simultaneously with the communication. So you might think that would be complicated, but it turns out it's actually pretty easy to do. You just come here to let's see, controls, and then you click on this new processor. Yeah, and then you just specify the function that you want. So in this case, I'll go here to functions, and I'll run the blink. That's all there is to it. Okay? So now the program, this is my main program here, this part at the top. That's going to run the blink function. Well, first of all, it's going to initialize the delay variable, and then it's going to tell the blink function to run in its own core. And then after
You have a
that,
bunch of functions and just shove them into another kind of a function and run as a program. Yeah, that's pretty sweet.
yeah,
So as it is right now, if you ran it, it would blink for 1 second until you entered the different value?
that's right. The light would stay on for a second and off, and then on and off for 1 second each until you put in a different value.
Okay.
So there's no way of specifying which core, or is there a separate block that lets you specify, say you want it in core 1 and 4
Right.
versus 1, 2, 3, 4, so on and so forth, down to 8?
Right. So in the block language, there's no way to specify a specific core number. You can, in the C language that you can use, you are allowed to specify specific cores, but not in the block language.
So if you just edit, you get the main code and then edit yourself.
If you really needed to specify a core, yeah.
I just wanted to know if there was a way to do it.
Yeah.
How do you, like, you got 8 cogs, like, how do you access the cogs? How do you-
Well, this is, so when I talk about cores,
The
that's what I'm
function.
talking about. Parallax calls them cogs, so that's just another name for it, but I'm using the word core. You can use them interchangeably. Oh,
Does it
yeah.
matter in the order that you put them?
The,
so if you were to put
whether
one-
you,
Yeah, so if you put the blink function at the bottom and the communication on the other core, does it matter? Or?
So I believe that it would not matter in this case. Yeah, they would both happen.
At the same time, so.
Well, one would happen first, but it would be so fast that you wouldn't really be able to tell. So I think that it would not matter. Yeah. Okay, so let's run this and see what happens.
So that's cores, and so the cores are actually the different functions.
So I've written 2 functions, and I'm telling one function to run on its own core, and then the communication function is just going to run on the main core.
Run function. So basically functions are cores.
No,
They're
no,
not.
they're not. Functions are just little blocks of code. So remember last time we had 4 different functions. We had forward, backward, turn left, turn right. And we called all of those at different times, and they were all running on one single core.
Oh, wow.
We could only run one of them at a time, but at different points in the program, we were using those functions. So functions are really just little blocks of code. Cores are physical
The chip actually-
parts of the chip itself
So it's
that
like
actually
8
does
chips all in
processing.
one.
So yeah, it's like having 8 different processors all in one package.
So,
So each core, each little processor can do its own thing by itself.
so you can't just say, okay, I want to make I made one, like say a mobile with one core, and say the other core I want to make something else. Like say light up LEDs, say,
Right.
of like to control the LED blinking and stuff like that on the
Right.
mobile. So it's like, how do you do that?
That's what we're doing. We
Okay.
wrote a function called blink, and we're going to run it in its own core.
Okay, so where's the mobile, like how do you get this thing distinguished?
How do we get it to what?
Distinguish like one after the other, or do they run simultaneous?
They run simultaneously, really physically at the same time. A lot of
Oh, yeah.
programs or a lot of computers will run several tasks at the same time, and it seems like they're actually happening simultaneously, but what's really happening is that the one processor is just scheduling time on each task. So it does one thing for a while, and then it stops and it does something else and stops and does something else. That's what happens on one processor. But since we really do have physically different spaces, physically different locations, different processors inside of the propeller chip, each processor can actually be doing different things at the same time. So you can have several tasks really truly running at the same time.
Oh, yeah, you can build like a helicopter or something with this system too.
Yeah, in fact they did. They
Yeah,
call it the
L05.
L05, and it's a quadcopter, and
Oh,
it
wow.
runs on this chip.
Nice.
So they use like a two core.
Yeah, so I don't want to get into that too much right now. Let's run this program. I'd be happy to talk to you more about it
Okay.
afterwards.
Yeah, I need to ask like how,
Yeah, so let's run this for right now. So when I run this program, it succeeded. Let's turn on the overhead projector there so we can see what's going on. So this will just take a minute to fire up. There it goes.
Oh, there's blinking.
okay, there's one in the light.
Yeah, so you can see that the light is blinking.
Nice.
There's a refresh rate issue, so you can't tell exactly how quickly the light's going on. If I hold this up, can you guys see this
Yeah.
light?
Yeah.
All right, so that'll be better.
You mean a refresh rate with the camera?
Yeah, the camera,
Okay, so-
exactly.
okay.
The camera only refreshes every 1 second or
Yeah.
something.
Yeah.
So if the light is blinking at about that rate, it looks weird. Anyway, so
Oh, wow.
now I'm going to enter a delay time in milliseconds here. So I'll make this 250 milliseconds. And as soon as I type that in and hit enter, the light starts blinking much faster. So
Yeah, nice.
yeah, so
Yeah, there it is right there.
yeah, we were able to do the communication on one core and read that value and store it in a variable. And then the other core was able to read that variable and update its action based on that new information. Okay? Yeah.
So if you wanted to change it again, all you have to do is just type it again because it didn't click the new line, so I don't know.
Right. So I haven't put that part in the program yet. So my communication function doesn't have a loop in it right now. So right now the communication function only runs one time, but I can definitely put in a loop to make it more user-friendly. So I'll go up here to control.
Can you
and then-
set like a hotkey or something instead of keeping it in a loop?
What, I'm sorry, what do you mean?
Can you set it as like a hotkey instead of keeping it in a loop?
Set, what is it?
The function itself. Like if you press, say
Oh, I
A,
see
it
what you mean.
would bring up the window to say you want to change it.
I see. I don't know of a way to do that.
Okay.
It may be possible, but I don't know how to do that.
I'd get a communicator or something in there for that, right? Trying to look at the different things.
Yeah, you can play around with it. I haven't heard of that ability, but it may be there. So that's definitely some place where you can experiment and try things out. So the last thing we can do is we can do a little bit more communication. And then just to make it a little bit prettier.
Scoop that up.
Yep, sure did. All right. And then, yeah. So that should put it in a loop and allow us to do it over and over again.
What goes on.
All right, so now we've started the program over. We're blinking 1 time per second. So now I can enter something like 100 milliseconds, and then press enter. And now the light's blinking much faster, and it asks us again to enter a new time. So yeah, so I can make it 500 now, and then
Nice.
the light updates. So yeah, so that's how it works.
So what's the timing? So that's 500 like millisecond blink or something like that?
Yes, exactly. The light. So let's look at our code again. We put that number in this delay time variable, and then that delay time variable is used in our blink function. So the light stays on for that many milliseconds, and then it stays off for that many milliseconds. Yeah.
So how would you get it to where it's not stacked on top of itself in the text side of things, where immediately after you put in the thing or the amount of time is now this, would you, or enter, please enter a different thing, how would you get another line? Space. Or another space in between the rows? Or if anything, just enter another terminal print new line?
Yeah, that's probably what I would do. So terminal, there we go, print new line.
Oh, yeah, that works.
So,
Nice.
That'd be on right at the bottom, just so there's no space between it.
yep, there you go.
One simple thing, answer my question.
Glad it was that easy. Yeah, so questions about that? All right, so you guys are going to build that up. Like I said, you're going to be free to play around with the code, try things out. We're going to have a few more people print out their name tags today. We got some from last time. I think that one of the name tags got deleted and one of them didn't have anything in it. So we'll have to take a look at that, but we got a couple of them printed off from last time. And I might just ask for a few more volunteers.
Don't delete them.
Yeah, right, we don't want to delete them. So I'll ask for a couple of volunteers and people to print them out. Everybody's going to have to print them out at some time during the semester. So if you have your name tag and it's ready to go, I would recommend doing it sooner rather than later.
Pay me the volunteer.
Okay, so any questions before we move on? Yeah.
Would you take a snip of it again?
Yes, yeah, exactly. Thank you. When you're done, please take a screenshot or a snip and then upload it to the Canvas. There's something I wanted to point out about that. Let me show you here for a second. So if you go here to assignments, the default view for assignments is this show by date thing. Now, none of the assignments really have due dates because they're all due just by the end of the semester. So that doesn't make them very organized. What I do is I show by type. When you do that, then they're actually all in order. Okay, so we did our name tag first, and then the car assembly, and then there's the printing, and then all of the other assignments are in order. So that should make it more clear what assignment we're working on. So today you'll upload to the serial terminal and blink group. Here. And then if you click on that, that should have that pseudocode available as well in case you need to jog your memory.
Oh, what's the, like, talking about input device, like, Mobile?
Yeah.
Like, what do you use for that? It's not, is it a photo, diary?
We're going to use a photo sensor, yeah, and we'll talk more about that in later class. Yeah.
What room are we in?
Yeah, we're back in 308. Anything else? All right, then let me take, hold on. Let me take 10 minutes before you go.
Dude, this is a bug going around here.
Hassan Al-Indi?
Here.
Jonathan Borchard?
Here.
Jacob Bronson?
Present.
Michael Chambers?
There's me.
Harold Cusco?
Here.
Dave Daly? Kyle Doyle? Kyle? Department Fasola?
Here.
Andy Hernandez?
Here.
Chase Holmes?
Here.
Milton Fawn?
Here.
Melissa Houston? Austin Kettle?
Here.
Philip Lozano?
Here.
Ben McNeely?
Here.
Jerry Mendez Gonzalez?
Here.
Chu Mua?
Here.
Aaron Rooks?
Here.
Jennifer Ross?
Got that.
Harrison Slaubaugh?
Here.
Kai Tran?
Here.
Ricky? Bill Weechek?
Here.
Jason Wilkes?
Here.
And Vyacheslav Zenko?
Here.
All right, thanks.
Yeah, interesting, man. That guy always tries to give me a bunch of damn lectures. He's like a 17-year-old, I mean, 17 right now, 17-year-old
Okay.
know-it-all, man. Oh, man. There's a lot of agriculture jobs going around. Like design, dang, I had like interviews like with designer positions. And
So how thin is ground? Eighth of an inch,
Yeah.
quarter of an inch, eighth?
8 is
and some interview with robotic mechatronic type of stuff too.
Mm-hmm.
It's like, looks like